Now, in this lecture, we'll find out the area of the green shape using two different methods. In the drawing, we have square ABCD. One side of square ABCD equals to 10 units. Inside the square, we have two semicircles that intersect with each other. The first semicircle is CPD and the second semicircle is the APD. They intersect with each other and create this blue lens. A lens is the common area that was created by the intersection of those two semicircles with each other. In addition, we have here quarter circle ABQD that intersects with this semicircle, and they create the big lens. Okay. The big lens was created by the intersection of the semicircle with the quarter circle. And our mission is to find out the area of this green shape. So it is very easy to see from the drawing that the area of this green shape equals to the area of the big lens minus the area of the blue lens. So I write it down. The area of this orange shape that we are looking for equals to the area of the big lens minus the area of the blue lens. Repeat again, the area we are looking for, that is the area of the orange shape, equals to the area of the big lens minus the area of the blue lens. Okay. So we find out the area of this orange shape in two different methods. In the first method, we will find out a formula for the area of a lens that was created by two shapes that are perpendicular to each other. Why? Because here the blue shape, this blue shape was created by the intersection of those two semicircles, and the two semicircles perpendicular to each other, and also the big lens was created by the intersection of the quarter circle with this semicircle, and you can see that this semicircle is perpendicular to this quarter circle, that is to say this angle ADC equals to 90 degrees. So both the big lens and the blue lens, they were created by the intersection of two shapes that are perpendicular to each other. So we create a general formula that gives us the area of a lens that was created by two shapes that are perpendicular to each other. Okay, so actually here we have those two semicircles that they are perpendicular to each other. That is to say, this angle equals 90 degrees. And we will define the radius of this semicircle as A. We define the radius of this semicircle as B. And then we will find out the area of this lens that could be the blue lens, and this lens also could be the big lens. And then we'll use the formula that we will create here in order to find out the area of the blue lens. Then we will use the same formula in order to find out the area of the big lens. We subtract the two areas from each other, and the result will be the area of this orange shape. Okay, because you can see from the drawing that the big lens, the area of the big lens minus the area of the blue lens is equal to the area of the orange shape. Okay, so here, as I already mentioned, this lens would be the blue lens because the two shapes are perpendicular to each other. This angle equals to 90 degrees. And this lens also could be the big lens because of the fact that here the big lens is created by the intersection of the quarter circle with this semicircle. And you can see that the angle between the quarter circle and the semicircle is equal to 90 degrees. Okay, so that is the reason that we can use the formula that we will create for both purposes, to find out the area of the blue lens and to find out also the area of the big lens. Okay, this will be the first method. In the second method, we'll find out directly the area of this blue lens that was created by the intersection of the two semicircles with each other. We'll find out the area of the big lens directly, that the big lens was created, as I already mentioned, by the intersection of the quarter circle with this semicircle. And then we subtract the two areas from each other, and this will be the area of this orange shape. Okay, so First of all, I will clarify two concepts. The first concept is the area of a sector Now, what is the area of a sector? The green shape is a sector that is a portion of a circle. So what is the area of this green shape that is a sector? It is actually equals to the ratio, the area of the sector, the green shape, is equals to the ratio between angle theta, that is the angle between the legs of the sector, over 2 pi, that is equal to 360 degrees. 2 pi radians is equal to 360 degrees. So when the ratio between the two angles gives us the relative percentage that the sector occupies out of the area of the entire circle, and when we multiply that ratio by the area of the entire circle, it will give us exactly the area of this sector, that is the green shape. Okay, so it is theta over 2 pi, and 2 pi radians is 360 degrees. That ratio between the two legs gives us the relative percentage that this sector occupies out of the area of the entire circle, and when we will multiply that percentage by the area of the entire circle, it will give us exactly the area of the sector. So theta over 2 pi times pi r squared, that is the area of the circle, because the radius of this circle is r, equals to the area of this sector, that is the green shape. Okay, so this is the first concept, and the second concept is the area of this circular segment AB. So you can see from the drawing, the green shape was created by this arc AB, and this arc AB, and the chord that attached to this arc. Okay, and the area of this circular segment AB equals to the area of sector A or B minus the area of triangle A or B. It is very easy to see from the drawing that the area of sector A or B is sector A or B minus the area of triangle A or B gives us exactly the area of the circular segment AB, that is this green shade. Okay. So we start with the first method, and as I already mentioned, in the first method we will take those two semicircles that are perpendicular to each other, and because of the fact that they are perpendicular to each other, it means that this angle equals to 90 degrees. And we will create a formula that will give us the area of this length, and the length is a common area that belongs to both semicircles, and was created by the intersection of those two semicircles with each other. Okay, so here we will define the radius of this semicircle as A. Here, this point is A, O, this point is M. Here, point O is the center of this semicircle, point M is a point on the semicircle itself, therefore OM, line segment OM is the radius of this semicircle that we define this A. Here, what is the definition of line segment LO? Here, point O is the center of this semicircle. Point L is a point on the semicircle itself, therefore line segment LO is defined as the radius of this semicircle that is equal to A units according to our definition. We will define the center of this semicircle as N. So what is the definition of line segment NL? L is the center of this semicircle. Point L is a point on this semicircle itself. This is exactly the definition of a radius. So that is to say NL is the radius of this semicircle, and we'll define the radius of this semicircle as B, so NL equals to B. Likewise, point N here point N is the center of this semicircle, point M is the point on this semicircle itself, therefore NM is the radius of this semicircle, that is equal to B units according to our definition. So here QL is tangent to this semicircle at point L. Point L is the point of tendency. Of tangent OL with this semicircle. And we have the radius NL that is drawn to the point of tendency. That is to say, it is drawn to point L, that is the point of tendency of tangent OL with this semicircle. And whenever we have a radius that is drawn to the point of tendency, then tangent OL will be perpendicular to the radius LN. So if OL is perpendicular to LN, it means that this angle equals to 90 degrees. According to rule number 1, that the tangent to a circle is perpendicular to the radius drawn to its point of tendency. In the next step, so now you can see here that the radius A can be any positive number, and that is the radius of this semicircle can be only any positive number, and the radius B and the radius of this circle also can be any positive number, and that is the reason that the formula that we develop for the area of this lens, it will be good in order to find out the area of the blue lens and the area also of the big lens. Why? Because here the radius A could be equal also to 10, and 10 is the radius of the quarter circle, and the radius A or B also can be equal to 5 units, and we will find out that the radius of each semicircle equals to 5 units. That is the reason, and both the semicircles, the two semicircles are perpendicular to each other, and this was created, that the intersection between the two semicircles created the blue lens, while the intersection with, or the intersection of the quarter circle with this semicircle created the big lens. And the radius of the big lens equals to 10 units, but here A can be equal to 10 units, that is the reason, and here B can be equal to 5 units, that is the radius of the semicircle. And we know that the quarter circle is perpendicular to this semicircle. This angle equals to 90 degrees. This is the leg of the quarter circle that is perpendicular to the leg of this semicircle. This angle equals to 90 degrees. So both shapes, so both the blue lens and the big lens, they were created by the intersection of two shapes that are perpendicular to each other, and here, because of the fact, so here we have those two semicircles that are perpendicular to each other, that is to say this angle equals to 90 degrees. So for that reason, this shape, this lens could be the blue lens if A equals to 5 units and B equals to 5 units, because here the blue lens is created by the intersection of the two semicircles with each other, and they have the same radii that is equal to 5 units, while here the intersection of the quarter circle with the semicircle created the big lens, and the radius of the quarter circle equals to 10 units. So here A would be equal to 10, and here B could be equal to 5 units. For that reason, the formula that we will develop for the area of this lens could be used in order to find out the area of the blue lens and then the area of this big lens. Okay? So here, so our mission is to find out the area of this big lens, and this big lens could be the blue lens, and it is also could be the big lens. Therefore, we will use the new formula that we will develop in order to find out the area of the blue lens and also the area of the big lens. Okay? So here we will join points M and N together by a straight line. So here we divided the lens into two parts. We'll find the area of each part. This is the upper circular segment ML, this is the lower circular segment ML, and then we'll add the two areas with each other, and this will give us the area of this lens that could be either the blue lens or the big lens. In the next step, we'll join points O and N together by a straight line. So in the first step, we will find out the area of this, the upper circular segment of this lens, the green shape. So, what is the area of the upper circular segment ML? The area of the upper circular segment ML equals to the area of sector MOL, the area of this sector, So this is sector MOL, and we will subtract the area of triangle MOL from the area of this sector MOL. So it is equal, the area of this circular segment ML equals to the area of sector MOL minus the area of triangle MOL. I repeat again, the area of circular segment ML equals to the area of sector MOL minus the area of triangle MOL. It is very easy to see from the drawing that if you subtract the area of triangle MOL from the area of this sector MOL, you will get exactly the area of circular segment ML. Okay. So now we have to find out the area of sector MOL. In order to find out the area of sector MOL, we have to find out the size of angle MOL, that is the angle between the legs of sector MOL. So we have to find out the size of this angle. So first of all, we define angle MON. This angle is theta. Then it is very easy to see that those two triangles can go into each other according to side rule. I will explain what I mean. That is to say, triangle MOL, this triangle can go into triangle OLN, this triangle, according to side rule. Here, those two sides, they are both equal to A, therefore they are equal to each other. In addition, those two sides, they are both equal to B, therefore they are equal to each other. And finally, NO is a common angle that belongs to both triangles. Therefore, this side equals to itself. So, actually we found out that those two right triangles can go into each other according to side rule. And from the fact that the two triangles can go into each other, we conclude that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. But according to our definition, this angle equals to theta. Therefore, this angle must be also equal to theta because of the fact that they can go into each other. They are equal to each other. So this angle must be also equal to theta. So in conclusion, we found out that angle MOL equals to theta plus theta, that is 2 theta. It is the angle between the legs of sector MOL. So here MO equals to A, OL also equals to A. So what is the area of sector MOL? The area of sector MOL equals to the angle between his legs, that is 2 theta over 2 pi radians. 2 pi radians equals to 360 degrees. So the ratio between these two angles gives us the relative percentage that the relative percentage that this sector occupies the relative percentage of the area that this sector occupies out of the entire area of the circle, and then when we multiply this relative percentage by the area of this circle, it will give us exactly the area of this sector. So here the area of the circle is pi r square and r equals to a, so it is pi times a square. So again, the relative percentage that the relative percentage of the area that this sector occupies out of the area of the entire circle times the area of the entire circle will give us exactly the area of this sector. So here we have pi in the numerator and pi in the denominator, so pi will get cancelled. We have 2 in the numerator and 2 in the denominator, so 2 also will get cancelled. So in conclusion, we found out that the area of sector MOL equals to theta a square. We have to subtract also the area of triangle MOL, but we'll do it later. So I write it down. It is minus the area of triangle MOL. We don't have to calculate the area. We'll do it later in a different way. In conclusion, the area of circular segment ML equals to theta e square minus the area of triangle MOL. In the next step, we'll find out the area of the lower circular segment ML. The area of this green shape, that is the area of circular segment ML. So what is the area of circular segment ML? The lower circular segment ML the area of this lower circular segment ML will be equal to the area of sector MNL, the area of this sector, this is sector MNL, minus the area of triangle MNL. And this is triangle MNL. It is very easy to see from the drawing that if you subtract the area of triangle MNL from the area of sector MNL, we get exactly the area of circular segment or the lower circular segment ML. Okay. So what is the area of sector MNL? In order to find out the area of this sector MNL, we have to find out the size of this angle. So first of all, this angle equals to theta, this angle equals to 90 degrees, therefore this angle equals to 90 degrees minus theta. But here we used radians, so 90 degrees is pi over 2 radians. So this angle equals to 90 degrees minus theta is pi over 2 minus theta radians. And in this triangle OLN, this angle equals to theta, this angle equals to 90 degrees, so this angle must be also equal to 90 degrees minus theta, or in terms of radians, 90 degrees is pi over 2, so it is pi over 2 minus theta. So both pi over 2 is in terms of radians, and theta is in terms of radians. So in conclusion, the size of angle MNL equals to the sum of those two angles. Okay, so it is equal to pi over 2 minus theta plus pi over 2 minus theta. So here pi over 2 plus pi over 2 is pi, minus theta plus minus theta is minus 2 theta. So in conclusion, we found out that angle MNL equals to pi minus 2 theta. So the size of the angle between the legs of sector MNL equals to pi minus 2 theta. And the area of sector MNL, as I already mentioned, the area of any sector equals to the size of the angle between its legs, that is pi minus 2 theta, over the size of the angle, that is the angle of the whole circle, that is 2 pi radians or 360 degrees in terms of degrees. So this ratio gives us the relative percentage that the sector occupy out of the area of the entire circle, and we will multiply this percentage by the area of the entire circle, that is pi r square, and here r equals to b, so it is pi b square. This will give us exactly the area of this sector for sector MNL. So here we have pi in the numerator and pi in the denominator, so pi will get cancelled. In the next step, we will open the brackets here, and we will get that this expression equals to pi times b square over 2 minus 2 theta over 2 times b square. So here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. And in conclusion, we found out that the area of sector MNL equals to pi b square over 2 minus theta times b square. And we also have to subtract from the area of sector MNL, the area of triangle MNL. Okay, so this is triangle MNL. This is triangle MNL. And we know that the sum of the areas of the upper circular segment plus the area of the lower circular segment will give us the area of this length. So we will add the two areas together and we will get the area of this length. Okay? So the area of this length that could be the blue lens or the big lens. The area of this length equals to the area of the upper circular segment, that is equal to theta times a square minus the area of triangle MOL that is the area of the upper circular segment ML, the green shape, plus the area of the lower circular segment, the orange shape. And we have already found out that the area of the lower circular segment ML equals to pi b square over 2 minus theta b square, that is the area of sector MNL, minus the area of triangle MNL. Okay, so in conclusion, we have to add here, we'll open here the brackets and we get that the area of this length, it is equal to theta times a square plus pi b square over 2 minus theta b square plus, it is actually minus, it is minus the sum of the areas of the two triangles, minus the area. So here we have negative sign and negative sign. So here, if we take minus 1 and second order, we get that it is minus the sum of those two areas of those two triangles. So it is here triangle MOL plus the area of triangle MNL. That is to say, we have to subtract the sum of the areas of those two triangles. So, therefore, we will find out the area of those two triangles and we will subtract it from this sum. In order to find out the area of those two triangles, we'll combine them together. This angle equals to 90 degrees. This angle equals to 90 degrees. So we combined the two triangles together. In the next step, we join points N and O together by a straight line. By joining points N and O together by a straight line, we created here two right triangles. We calculate the area of each right triangle, we will add them together. This will be the sum of the areas of those two triangles. The area of the green right triangle OML equals to the base of the triangle that is B times the height of the base that is A over 2. While the area of the orange right triangle equals to the base of the triangle that is A times the height of the base that is B over 2. BA and AB is the same, so BA plus AB, it is equal to 2AB over 2. We have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. So it is equal to AB. In conclusion, we found out that the sum of the areas of those two triangles is AB. So we have to subtract AB from this expression, and this will give us exactly the area of this length. That could be the blue lens or the big lens. Okay. So, in conclusion, I found out that the area of the lens equals to this expression that is theta A square plus pi p square over 2 minus theta p square. So it is equal to this expression minus the area of the two triangles, that is actually AB, so it is minus AB. Okay, so in conclusion, I found out that the area of this length equals to this expression. In the next step, we take theta as a common factor out of these two expressions. So theta is a common factor. What is left from this expression after we took from it theta as a common factor? What is left is actually a square. And what is left from this expression after we took from it theta as a common factor? What is left is actually minus b squared. Okay, so here we have also pi b squared over 2 minus AB. That is the area of this length. That could be the blue length, and also it could be the big length as I have already showed to you. Now, so we have here the variables that we have here, A and B are the radii of the two shapes that intersect with each other, and theta, actually we want to eliminate theta because we want that the only variables that we will have in this formula for the area of a length will be only the radii of the two shapes that intersect with each other and create the length. So, in order to find out the value of theta, I will draw the right triangle MON that contains angle theta, and will derive the value of angle theta from this right triangle MNMO. Okay. The right triangle MNO, it's very easy to see that tangent theta equals to MN over MO. Okay, MN equals to B, MO equals to A, so in conclusion we found out that tangent theta equals to B over A. But we want to find out the theta itself and not tangent theta, so we will operate the opposite function of tangents on the result, that is B over A, and this will give us the value of theta itself. So theta itself is equal to tangents minus 1, that is the opposite function of tangents. We will operate the opposite function of tangents on the result, that is B over A, and this gives us the value of theta. Now we can substitute theta by tangents minus 1 of B over A, so now we have the only missing variable that we have in the formula for the area of a lens. The only missing variables that we have here are A and B, that are the radii of the two shapes that intersect with each other. So now we'll substitute theta by tangent minus 1 of b over a, and we'll multiply it by a squared minus b squared plus pi b squared over 2 minus ab. So we actually found out that the area of a lens that could be the blue lens or the big lens equals to this expression, tangent minus 1 of b over a times a squared minus b squared plus pi b squared minus ab. Here a and b are the radii of the two shapes that intersect with each other. Now we can use this formula in order to find out the area of the big lens. We'll use the same formula, this formula, in order to find out the area of the blue lens. We'll subtract the two areas from each other, and this will give us the area of the orange shape. So first of all, we'll find out, we use this formula in order to find out the area of the big lens. The area of this big lens. So here it is very easy to see that this big lens was created by the intersection of the quarter circle with this semicircle. Again, the intersection of this quarter circle with this semicircle created this blue lens. As I already mentioned, the radius of the quarter circle is 10 units. That is to say, A equals to 10. The radius of this semicircle, what is the radius of this semicircle? We know that the diameter is 10. The diameter is 10, therefore the radius must be equal to 5. So B equals to 5. So we know that A equals to 10, B equals to 5, so we'll put the values of A and B inside this formula, and we'll find out the area of the big lens. So here we'll get that tangent minus 1 of B over A. B is 5 and A is 10, so 5 over 10 is 1/2, and 1/2 is 0.5. Times A squared. A is 10, so A squared is 10 squared. Minus B squared. B is 5, so B squared is 5 squared. Plus pi, B is 5, so B squared is 5 squared over 2. Minus A is 10 and B is 5, so it is minus 10 times 5. So we found out that the area of the big lens it is equal to tangents minus 1 of 0.5. Here we have to multiply it by 10 squared, that is 100, minus 5 squared, that is 25. 100 minus 25 is 75, so we have to multiply it by 75. And we have to add here pi 5 square. 5 square is 25. 25 over 2 is 12.5. So in conclusion, this expression equals to 12.5 pi. We also have to subtract here, minus 10 times 5 is minus 50. So in conclusion, we found out that the area of the big lens equals to this expression, 75 times tangents minus 1 of 0.5 plus 12.5 pi minus 50. Okay? This is the area of the big lens. In the next step, we'll use the sum formula in order to find out the area of the blue lens, and we'll subtract the areas from each other, and this will give us the area that we are looking for, the area of the orange shape. So what is the area of the blue lens? The area of this blue lens it is very easy to see from the drawing that this blue lens was created by the intersection of the two semicircles with each other. Okay, the intersection of those two semicircles created here common area that is defined as the area of the blue lens. And we know that the radii of each semicircle equals to 5 units, that is to say A equals to 5 and B also equals to 5. So we'll put the value of A and B inside this formula. As I already mentioned, this formula is good in order to find out the area of the big lens, and it is also good in order to find out the area of the blue lens. Why? Because the two shapes that created the lens, they are both perpendicular to each other. Okay, and we took A and B, that could be any radii. So that could be the blue lens and also the big lens. So the blue lens, here A equals to 5 and B equals to 5, so we get here, we put the values of A and B in this formula, and we get that the area of the blue lens equals to tangents minus 1 of B over A. B is 5, A is 5, so 5 over 5 is 1, times A squared minus B squared. A equals to 5, so A squared is 5 squared, minus B squared. B is 5, so B squared is 5 squared. A equals to B, so A squared minus B squared will be equal to 0. So therefore, this expression, 5 squared minus 5 squared is 0, so this expression will be equal to 0. And we have to add also pi B squared. B equals to 5, so B squared is 5 squared, and 5 squared over 2 is 12.5. So in conclusion, this expression equals to 12.5 pi. And we have to subtract here A times B. A is 5, B is 5, and minus 5 times 5 is minus 25. So here this expression equals to 0. So in conclusion, we found out that the area of the blue lens equals to 12.5 pi minus 25 square units we have already found out that the area of the big lens equals to 75 times 10 minus 1 times minus 1 0.5 plus 12.5 pi minus 50, and as I've already mentioned before, the area of the orange shape the area of this orange shape equals to the area of the big lens minus the area of the blue lens. Okay, so the area of the orange shape equals to the area of the big lens, that is equals to 75 times 10 minus 1 of 0.5 plus 12.5 pi minus 50. This is the area of the big lens, and we have to subtract from it the area of the blue lens, that is equal to, so it is minus, that is equal to 12.5 pi minus 25 square units. So square units, so we will open the brackets here, and we'll get that the area of the orange shape equals to 75 times 10 minus 1 of 0.5 plus 12.5 pi minus 50. We'll open the brackets here, and we'll get here that is minus 12.5 pi, minus and minus is plus, so it is minus 25 is plus 25. Okay, so we have here 12.5 pi minus 12.5 pi is 0, so those two expressions will get cancelled, and we have minus 50 plus 25 is minus 25. So in conclusion, we found out that the area of the orange shape equals to 75 times 10 minus 1 of 0.5 minus 25. But we know that the value of tangents minus 1 of 0.5, it is actually equals to 0.46. Therefore, we'll substitute tangents minus 1 of 0.5 by 0.46, and we get that the area of the orange shape equals to 75 times tangents minus 1 of 0.5 is 0.46 minus 25. So in conclusion, we found out that the area of the orange shape equals to 75 times 0.46 is 34.77 minus 25, and 34.77 minus 25 is 9.77 square units. So in conclusion, we found out that the area of the orange shape is equal to 9.77 square units. Okay. The area of this orange shape dpq equals to 9.77 square units. So we finish with the first method. In the next step I present to you how to find out the area of this orange shape according to the second method. In the second method, we directly calculate the area of this orange blue lens. We directly calculate the area of this big lens. We'll subtract the areas from each other, and this will give us the area of this orange shape. Okay? So, in the first step, we calculate the area of this blue lens. Okay? So repeat again, our mission was to find out the area of this blue lens. Finding out the area of the blue lens. As I already mentioned, this blue lens was created by the intersection of those two semicircles with each other. The common area that was created by the intersection of those two semicircles with each other is defined as this blue lens. So here I drew the two lenses with each other, and this common area is defined as the blue lens. Now we have to calculate the area of this blue lens. We have already found out that the radii of the two semicircles they're both equal to 5. We can use here the drawing from the first method. If we put here A equals to 5 and B equals to 5, then we get exactly the area of the blue lens. First of all, as I already mentioned, the two semicircles are perpendicular to each other, that is to say, this angle equals to 90 degrees. And we know that the radii of the two semicircles, it is equal to 5. So here, this is the center of this semicircle, and this is point L, so we know that OL equals to 5 units. And because of the fact that the two semicircles have the same radii, that is to say they are identical, and for that reason, when we will draw this radius that is perpendicular to the diameter the diameter of this semicircle, it means that this angle must be equal to 90 degrees from one side, but from the other side, this radius, it will not be only perpendicular to the diameter MH, but it is also will be tangent to this semicircle at point L. So point L is the point of tendency. So the perpendicular radius that we will draw from the center of this semicircle, it will not only be perpendicular to the diameter, but it is also will be tangent to this semicircle at point L. Why? Because those two semicircles are identical. For that reason, the radius that is perpendicular to the diameter MH will be also tangent to this semicircle at point L. So this angle equals to 90 degrees. Okay, while in here we drew two semicircles that are not identical, therefore this radius and this angle could be any angle, not necessarily 90 degrees. Okay. So here, the center of this semicircle is at this point, point L, N, point L is, so point N is the point, is the center of this semicircle. Point L is a point on this semicircle itself, that is to say, NL is the radius of this semicircle, that is equal to 5 units. So here we have this radius of this semicircle. It is drawn to the point of tendency, that is to say, it is drawn to point L, that is the point of tendency. Actually here, this radius NL of this semicircle, it is drawn to the point of tendency, that is to say, it is drawn to point L, that is the point of tendency of tangent OL with this semicircle. Whenever you have a radius that is drawn to the point of tendency, then tangent OL will be perpendicular to the radius LN. So if OL is perpendicular to LN, it means that this angle equals to 90 degrees. Here, MN is the radius on this semicircle, that is equal to 5 units. We join points M and L together by a straight line. So here we divided the blue lens into 2 equal parts. We will calculate the area of this circular segment. We will multiply it by 2, and this will give us the area of this blue lens. I'll repeat again that the reason that those 2 circular segments are identical is because of the fact that those 2 semicircles are also identical and they are perpendicular to each other. For that reason, when they intersect with each other, it creates this lens, and when you join those 2 points together, you actually divide this lens into 2 equal parts, into 2 equal circular segments. That is to say, the area of this circular segment will be equal to the area of the lower circular segment. So if we multiply the area of this circular segment by 2, we'll get the area of this blue lens. So what is the area of the upper circular segment? It is very easy to see from the drawing that the area of the upper circular segment ML equals to the area of sector MOL. This sector is equal to the sector MOL this is sector MOL minus the area of triangle MOL. minus the area of triangle MOL. Triangle MOL is a right triangle. This is a right triangle, this angle equals 20 degrees. And because of the fact that this angle equals to 90 degrees, it means that sector MOL, this sector is a quarter circle. Okay? Sector MOL is a quarter circle, and we know that the area of any quarter circle equals to the area of the circle over 4. Okay? So the area of this sector MOL, because of the fact that it is a quarter circle, it is equal to the area of the circle, that is pi r squared, and r is 5, so it is pi times 5 squared over 4. Minus the area of triangle, the right triangle, triangle MOL. The area of triangle MOL equals to the base of the triangle, that is 5, times the height to the base, that is also 5, over 2. So actually we found out the area of circular segment, this circular segment ML. Okay, this is the area of circular segment ML. So here you can see that this angle equals to 90 degrees. This angle equals to 90 degrees. This angle also equals to 90 degrees. So here the missing angle, you know that the sum of the angles in any quadrilateral equals to 360 degrees. So this angle must be equal to 90 degrees. So if we will go in the long way, and we'll also calculate the area of this circular segment, we'll find out that the area of this circular segment will be equal to the area of sector M and L, but this angle equals to 90 degrees. So it is a quarter circle with radius of 5. So the area of this quarter circle will be equal to pi times 5 square over 4 minus the area of triangle M and L, that is a right triangle. Therefore, okay, I repeat again that the area of the lower circular segment will be equal to the area of sector M and L, but the sector M and L is a quarter circle because this angle equals 90 degrees. So the area of the quarter circle will be equal to pi times 5 square over 4 minus the area of this right triangle, that it also will be equal to 5 times 5 over 2. Okay? So in order to save the time, we see that it has exactly the same area. So we don't have to find out the area of the lower circular segment because it is the same area. So we will just multiply the area of this upper circular segment by 2, and this will give us the area of this blue lens. Again, those two circular segments are identical, therefore they have the same areas. So the area of circular segment and the area of the blue lens This is the blue lens, and the area of the blue lens equals to 2 times the area of circular segment ML. 2 times this expression. So it is 2 times pi times 5 square over 4, and here we have 2 times 5 times 5 over 2. Okay, so here we have 2 in the numerator, so here it is 4 actually. Here it is 4. So we divide both the numerator and the denominator by 2. So in the numerator we will have here pi times 5 square, and 4 over 2 is 2. Minus, we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. So here we have minus 5 times 5 is 25. So in conclusion, the area of the blue lens here we have 5 square is 25, 25 over 2 is 12.5. So in conclusion, this expression equals to 12.5 pi minus 25. So in conclusion, we found out that the area of the blue lens equals to 12.5 pi minus 25 square units. Okay. In the next step, we'll find out the area of the big lens, and then we'll subtract the two areas from each other, and this will give us the area of the round shape. So we'll find out the area of the big lens. It is very easy to see from the drawing that the big lens was created by the intersection of the quarter circle with this semicircle. Okay, here the big lens was created by intersection of this quarter circle by this semicircle. Okay, the common area is the big lens. Okay, so here this is the radius of the quarter circle that is equal to 10 units. So now our mission is to find out the area of the big lens. Okay? Okay, we find out the area of the big lens. As I've already mentioned, this semicircle is perpendicular to the quarter circle. Why? Because one side of the quarter circle is perpendicular to the other side of the semicircle. So this angle equals to 90 degrees. You can see it from the drawing. that the quarter circle, this quarter circle is perpendicular to this semicircle. So this angle equals to 90 degrees. So from the center, we define the center of this semicircle is point O. We define this point as point L. Point O is the center of the semicircle, point L is a point on the semicircle itself. That is to say, OL is the radius of this semicircle that is equal to 5 units. But OL is not only the radius of the semicircle, but it is also perpendicular to the semicircle at point L. So point L is the point of tendency. Point of tangency of tangent OL with this quarter circle. Okay. We'll join the two centers together by a straight line. This is the center of the quarter circle, of course. From the center of the quarter circle, we draw the radius in such a way that it will be tangent to this semicircle. So we'll actually draw it to this point, point L. Point N is the center of the quarter circle. Point L is a point on the quarter itself. That is to say, this is exactly the definition of a radius. So NL is the radius of this quarter circle that is equal to 10 units. So here we have the radius NL that is drawn to the point of tendency. That is to say, it is drawn to point L, that is the point of tendency of tangent OL in this quarter circle. And whenever you have a radius that is drawn to the point of tendency, then tangent OL will be perpendicular to the radius LN. So if OL is perpendicular to LN, it means that this angle equals to 90 degrees. So here we will first of all, here point O is the center of the semicircle, point M is the point of the semicircle itself. That is to say, OM is the radius of this semicircle that is equal to 5 units. So here we have those two triangles that can go into each other according to side rule. Okay, I'll explain why. First of all, those two sides are both equal to 10 units, therefore they are equal to each other. In addition, those two sides are both equal to 5 units, therefore they are equal to each other. And finally, NO is the common side that belongs to both triangles, therefore we actually proved that those two right triangles can go into each other according to side rule. Therefore, we can conclude from it that those two angles equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Okay, so we know that those two angles are equal to each other. So if we define this angle as theta, then this angle must be also equal to theta because of the fact that those two angles are equal to each other. Okay. In the next step, we'll join points M and L together by a straight line. Actually, the straight line ML divides the big length into two parts. This is the first part, this is the second part. So we will calculate the area of this big length in two steps. First of all, we'll calculate the area of the upper circular segment. In the next step, we'll calculate the area of the lower circular segment. We will add the two areas together. This will be the area of this big length. We will subtract the area, then the area of this big length minus the area of the blue length will give us exactly here. The area of the big length minus the area of the blue length will give us exactly the area of this orange shape. We have already found out the area of this blue length. The only thing that is left to do is to find out the area of this big length. So in the first step, we'll find out the area of this upper circular segment of this big length. But here, we'll focus on triangle ONM. In triangle ONM, this angle equals to theta, this angle equals to 90 degrees. So this angle must be equal to 90 degrees minus theta. In terms of radians, 90 degrees minus theta is pi over 2 minus theta. Likewise, in the right triangle OLN, this angle equals to theta, this angle equals to 90 degrees, so this angle must be equal to pi over 2 minus theta. And because of the fact that those two angles can go into each other, those two angles must be also equal to each other. Okay? So, what is the area of the upper circular segment ML? The area of the upper circular segment ML equals to the area of sector MNL, the area of this sector, this is sector NML. This is sector MNL. Minus the area of triangle MNL. Minus the area of triangle MNL. We know that the angle between the legs of sector M and L is theta plus theta, that is 2 theta. In addition, we know that Mn equals to Nl equals to 10 units. So, what is, you can see, it is very easy to see that if you subtract the area of triangle MNL from the area of sector MNL, you will get exactly the area of this sector, the upper sector, and the upper circular segment ML. Okay, so the area of the upper circular segment ML equals to the area of sector MNL. And the area of sector MNL equals to 2 theta over 2 pi times the area of the circle, that is pi r squared. R is 10, so r squared is 10 squared. So the area of the circle is pi 10 squared. So we have pi in the numerator and pi in the denominator, so pi will get cancelled. We have 2 in the numerator and 2 in the denominator, so 2 also will get cancelled. So in conclusion, we found out that the area of sector M and N equals to 10 squared is 100 times theta. We have to subtract from the area of sector M and N the area of triangle M and L. The area of triangle M and L equals to the multiplication of the two sides together. That is 10 times 10 times sinus the angle between the sides, that is 2 theta over 2. So in conclusion, we found out that the area of circular segment, the upper circular segment ML, equals to 100 times theta minus 10 times 10 is 100, and 100 over 2 is 50. 50 times sinus 2 theta. So write it down again, that the area of the upper circular segment ML equals to 100 times theta minus 50 times sinus 2 theta. Okay, in the next step we'll find out the value of theta, we'll find out the value of sinus 2 theta, and we'll substitute theta and sinus 2 theta by the values that we will find for them. In order to find out the value of theta and the value of sinus 2 theta, I will draw the right triangle MON that contains angle theta. We derive the value of theta and the value of sinus 2 theta from the right triangle MON that contains angle theta. So this is the right triangle NMO that I copied from the original drawing. Here, tangent theta equals to MO over MN. MO equals to 5, MN equals to 10. 5 over 10 is 1 half, that is 0.5. So in conclusion, we found out that tangent theta equals to 0.5. Now we will operate the opposite function on tangents on the result, and this operation will give us the value of theta itself. So theta will be equal to tangents minus 1 of 0.5. Okay, we found out the value of theta. It is equal to tangents minus 1, that is the opposite function of tangents of 0.5. In the next step we find out the value of sinus 2 theta, so I copy the right triangle again here. So in the right triangle MNO, we'll implement the Pythagoras theorem in order to find out the value of the hypotenuse, the length of the hypotenuse. So by PT, the evaluation for Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, NO square equals to MN squared, that is 10 squared, that is 100, plus MO square. MO is 5, so MO square is 5 squared, that is 25. So in conclusion, we found out that NO square equals to 100 plus 25 is 125. We take a root out of this equation and find out that NO equals to the square root of 125. And 125 is 25 times 5, so we substitute 125 by 25 times 5, and we'll get here that we take a root out of this equation and find out that the square root of 25 is 5, so it is 5 times square root of 5. So in conclusion, we found out that the hypotenuse NO equals to 5 times square root of 5. And we also know that sinus 2 theta equals to 2 times sinus theta cosine theta. So sinus 2 theta equals to 2 times. And what is the value of sinus theta from the triangle MNO? We can see that sinus theta equals to MO over ON. MO equals to 5, ON equals to 5 times square root of 5, so in conclusion, sinus theta equals to 5 over 5 times square root of 5. And we also have to multiply it by cosine theta. Cosine theta equals to MN over NO. MN is 10, and NO is 5 times square root of 5. So here we have 5 in the numerator and 5 in the denominator, so 5 will get cancelled. So in the numerator we have here 10 times 2. In the denominator we have square root of 5 times square root of 5 is 5. And we have also 5 here. And here 10 over 5 is 2, so in the numerator we have 2 times 2. And then the numerator what is left is only 5. 2 times 2 is 4. And the numerator we have 5, so in conclusion we found out that sinus 2 theta equals to 4/5. So, in conclusion, we found out that theta equals to tangents minus 1 of 0.5, while sinus 2 theta equals to 4/5. And we already found out that the area of the upper circular segment ML of the big lens is equal to 100 times theta minus 50 times sinus 2 theta. Now we substitute theta by tangents minus 1 of 0.5 and we substitute sinus 2 theta by 4/5. And we get that the area of the upper circular segment MN equals to 100 times tangents minus 1 of 0.5 minus 50 times sinus 2 theta, and sinus 2 theta equals to 4/5, so we substitute sinus 2 theta by 4/5, and we get that 100 times tangents minus 1 of 0.5 is equal to the area of the upper circular segment ML equals to 100 times tangents minus 1 of 0.5, and here we have minus 50 over 4, minus 50 over 4, minus 50 over 5 equals to minus 10, and minus 10 times 4 is minus 40. So in conclusion, I found out that the area of the upper circular segment ML is equal to 100 times tangents minus 1 of 0.5 minus 40. In the next step, we find out the area of the lower circular segment of the big lens, the area of this circular segment, the lower circular segment. So here I will draw again the big lens. So our mission is to find out the area of the lower circular segment, the area of the green shape. This is the lower circular segment ML. We have already found out that angle MON equals to pi over 2 minus theta. Angle NOL equals to also pi over 2 minus theta. And the sum of those two angles, they are equal to pi over 2 minus theta plus pi over 2 minus theta. So pi over 2 plus pi over 2 is pi, and minus theta plus minus theta is minus 2 theta. So in conclusion, we found out that the size of angle MOL, the size of this angle, is equal to pi minus 2 theta. Okay, so what is the area of the lower circular segment ML? The area of the lower circular segment ML it will be equal to the area of sector MOL, the area of this sector, so this is sector MOL, minus the area of triangle MOL. Minus the area of triangle MOL. So we know that the angle between the legs of sector MOL is pi minus 2 theta. Here it is also pi minus 2 theta. MO equals to 5, OL equals to 5. So the area of sector MOL equals to pi minus 2 theta over 2 pi times the area of the circle, that is pi r squared, and r is 5, so it is pi 5 squared. Here we open the bracket, here we have pi in the numerator and pi in the denominator, so pi will get cancelled. We'll open the brackets and we get that 5 squared is 25, so it is 25 pi over 2 minus 2 theta over 2 times 25. So here 25 over 2 is 12.5, so this expression in total equals to 25 pi. We have 2 in the denominator and 2 in the denominator, so 2 will get cancelled. So here we left only with minus 25 theta. And we have to subtract from it the area of triangle MOL. The area of triangle MOL equals to 5 times 5 times sinus pi minus 2 theta over 2. So it is 12.5 pi minus 25 theta, and then we have minus 25 over 2, and sinus pi minus 2 theta equals to sinus 2 theta. So it is equal to the area of the lower circular segment ML equals to 25 pi, 12.5 pi minus 25 times theta, and theta equals to tan minus 1 of 0.5 And we have to subtract also this minus 25 over 2, and sinus 2 theta equals to 4/5. So we substitute sinus 2 theta by 4/5, and we get that the area of the lower circular segment ML is equal to 12.5 pi minus 25 times tangents minus 1 of 0.5, and we have here 25 over 5 is 5, 5 times 4 is 20, and 20 over 2 is 10, so it is minus 10. Okay. In conclusion, the area of the lower circular segment ML equals to 12.5 pi minus 25 times tangent minus 1 of 0.5 minus 10. And we know that the area of the big lens equals to the area of the upper circular segment of the big lens plus the area of the lower circular segment of the big lens. Here, so I'll write it down. The area of the big lens equals to the area of the upper circular segment of the big lens plus the area of the lower circular segment of the big lens. That is to say, the area of the big lens equals to the area of the upper circular segment of the big lens equals to 100 times tangents minus 1 of 0.5 minus 40 plus the area of the lower circular segment, that is equal to 12.5 pi minus 25 times tangents minus 1 of 0.5 minus 10. So in conclusion, we found out that the area of the big lens equals to 100 times tangents minus 1 of 0.5 minus 25 tangents minus 1 of 0.5 is 75 times tangents 1 tangents minus 1 of 0.5 minus 40 minus 10 is minus 50, minus 40 plus minus 10 is minus 50, and we have also to add here plus 12.5 pi. This is the area of the big lens, and the area of the orange shape equals to the area of the big lens minus the area of the blue lens. That is to say, the area of the orange shape equals to the area of the big lens, that is 75 times tangents minus 1 of 0.5 minus 50 plus 12.5 pi minus the area of the big lens, that is equal to 12.5 pi minus 25. So here we'll open the brackets and we'll get that the area of the orange shape equals to 75 times tangents minus 1 of 0.5 minus 50 plus 12.5 pi. Here it is minus, we open the brackets here, so it is minus 12.5 pi, and we have minus with minus is plus, so minus 25 is plus 25. So here 12.5 pi minus 12.5 pi is 0, so those two expressions will get cancelled. And minus 50 plus 25 is minus 25. So in conclusion, we found out that the area of the orange shape equals to 75 times tangents minus 1 of 0.5 minus 25. But we know that tangents minus 1 of 0.5 equals to 0.46. So we substitute tangents minus 1 of 0.5 by 0.46, and we get that the area of the orange shape equals to 75, and tangents minus 1 of 0.56 is 0.46 minus 25. And 75 times 0.46 is 34.77, and we have to subtract from it 25, so it is 34.77 minus 25 equals to 9.77. So in conclusion, I found out that the area of the orange shape equals to 9.77 square units. I write it down here. We found out that the area of the orange shape equals to 9.77 square units. Okay. Here, according to the second method, we found out that the area of the orange shape equals to 9.77 square units. So, in the next step, I will summarize the lecture. So, here we found out the area of the green shape in two different methods. In the first method, we actually developed a formula that will help us to find out the area of the big lens and also the area of the blue lens, and then use to find out use the formula to find out the areas of the two lenses, and we subtracted the two areas from each other, and this gave us the area of the orange shape. While in the second method, we actually calculated directly the area of the big lens, then we calculated directly the area of the blue lens. We subtracted the two areas from each other, and this is the area of the orange shape. Okay. So here this lens, those two semicircles perpendicular to each other, and this is exactly what we have here in the drawing. In the drawing we have those two semicircles that are perpendicular to each other, and they create the blue area. the blue lens. Okay, and the big lens was created from the intersection of the quarter circle with this semicircle, and they are also perpendicular to each other. Therefore, we can draw here two semicircles that are perpendicular to each other, because the two shapes, the big lens and also the blue lens, they both created by two shapes that are perpendicular to each other. So it is right to draw here two semicircles that are perpendicular to each other, and then we define the radius of one semicircle as A, we define the radius of the other semicircle as B, and then when we will find out the area of this lens, the formula that we will create will be good in order to find out the area of the two semicircles that intersect with each other. We know that the two semicircles, they have the same radii that is equal to 5. Therefore, here A will be equal to B equal to 5 units. And in the second case, the big lens was created by the intersection of the quarter circle with this semicircle. And here the radius of the quarter circle equals to 10 units, so here A will be equal to 10, and the radius of the semicircle equals to 5 units, so B will be equal to 5, and because of the fact that the quarter circle is perpendicular to the semicircle, therefore our drawing is good for the area of the big lens. Okay, when A equals to 10 and B equals to 5, so here we will have the quarter circle that intersects with this semicircle, and they are perpendicular to each other. This will be the area of the big lens. Okay, so therefore the formula that we created here, it is good for both lenses. For the blue lens, that A equals to B equals to 5 units, and for the big lens, that A will be equal to 10, B equals to 5, and in both cases the two shapes are perpendicular to each other. Therefore, this angle equals to 90 degrees, so it will be good for the areas to find out the areas of both lenses, the area of the blue lens and the area of the big lens. Okay, that is the idea behind method 1, that we have here two semicircles that are perpendicular to each other, but with radii of A and B, that A and B could be any positive number, and especially A could be equal to B equal to 5 units, that will create the big lens. In the second case, A will be equal to 10, B will be equal to 5, and this will create the big lens. And because of the fact that both shapes in the original drawing are perpendicular to each other, therefore when we created those two semicircles that are perpendicular to each other, so there will be, the formula that we will create will be good for both lenses, for the blue lens and for the big lens. Okay, so that was the idea for in the first method, and in the second method we actually calculated directly the area of the big lens. So the big lens was created by intersection of the two semicircles with each other. So the radius of both semicircles, they are both equal to 5 units, and the big lens was created by the intersection of the quarter circle with this semicircle. We know that the radius of the quarter circle equals to 10 units, and the radius of the semicircle equals to 10 units, so we have enough data to find out directly the areas of both the blue lens and also the big lens without any general formula, but directly we found out the area of this blue lens. We know that the radius of both semicircles are equal to 5 units, while the radius of the quarter circle equals to 10 units, and the radius of the semicircle equals to 5 units. And the intersection of the quarter circle with the semicircle created the big lens. So we directly found out the areas of the big lens and the area of the blue lens. We subtracted the two areas from each other, and the result is the area of this orange shape. Okay, so in a sense, this is the idea behind the two methods, because of the fact that I don't have enough time here to explain the two methods in detail. I gave you the general idea for both methods, how we solved the question in two different methods. Okay, thank you very much.